You are filling in each blank by skip counting. I'm going to look at number 6 and number 7 with you, and then you can do 1 through 5 on your own. I see in number 7, from 450 to 456, that changed by 6. So I need to go in the middle. It's counting down. 456, 450, 444. So I need to go in the middle of 456 and 450, and we're counting down. That would be a change of 3. So 453. Then I'm going to change by 3 again to get to this one. If I go down 3, that puts me at 447. Here, from 357 to 336, that's going down as well. And it goes down, let's see, we have 357 minus 336. That would be 121. So I need to count up 21 to get to this one here. 357 plus 21 would put me at 378. And the first one is going to be 21 more than that, which is 399. You have a couple that are counting down, several that are counting up. Try and figure out what they're counting by and fill in the rest. Make a conjecture about the rule for each diagram. Numbers inside the circle follow the rule. Numbers outside the circle do not follow the rule. Each diagram represents a different rule. Think about what conclusions you can make based on the placement of these numbers. Make a hypothesis or a conjecture about the rule for each diagram. If you disagree with somebody, provide a number that does not follow the rule as a counterexample. For diagram A, I see that all of the numbers inside the circle are even, and the numbers outside of the circle are odd. So my hypothesis or my conjecture is that the rule for diagram A is that they are divisible by 2. If something is even, it's divisible by 2. In B, I see this is an odd, and here's an odd, but the rest are even. And 2 is out here. I see if it's in the circle, it either ends in a 0 or a 5. But out here, this doesn't end in a 0 or a 5. So my thought is that these are divisible by 5. Because if it's divisible by 5, it would end in a 5 or a 0. If we count up 5, 10, 15, 20, those all end in a 5 or a 0. In this one, I see they all end in 0. And they're all even. But on the outside, we have some odds and some evens that do not end in 0. All the numbers that end in 0 are divisible by 10. So that's my hypothesis or my conjecture for diagram C. Here I have diagrams D, E, and F. I see they're all even in diagram D, but that's not the case in E. And some evens are outside on diagram F. Why do we think 432 shows up in all of them? Today we're going to determine some rules for diagrams E and F, and we'll learn some strategies to determine whether a number such as 432 is divisible by anything else without actually having to use long division. We're going to learn some tricks for some divisibility rules as a quick way to check if something is divisible by another number without having to do long division. In number 2, it says group the blocks to determine whether 432 is divisible by 3. Draw and label your work to show your thinking. Okay, so if it's divisible by 3, I can separate it into 3 equal parts. So I'm going to use 3 different colors. So I'm going to put 100, 110, and a 1 together. $100, $110, and a 1 together. And now I need $100, $110, and a 1 together. Or I can use this 10 and one of these. Now I have 99 left to split amongst the red, blue, and green sections. I could take 30 for each color. And now I have 9 left. I could use 3 of each. So it is divisible by 3. Another way that we could separate this out is we can group it in groups of 3. So for example, here's 3 hundreds. Now we need 3 tens, 3 tens, 3 tens, 3 tens. Here's a group of 3. Another group of 3, 3, and 3. That's another way to show that it's divisible by 3, because all of these sections are made up of 3 pieces. 3 hundreds, 3 tens, 3 ones. So we can split those into 3 parts. Here we have 1 taken out from each 100 and each 10. So now I have 9 ones floating around. You can think of this as 4 from the hundreds, 3 from the tens, and 2 from the ones to make 432. So this divisibility rule for 3, there's 4, 5, 6, 7, 8, 9. If I add up all those digits, 4 plus 3 plus 2 gives me 9. And 9 is divisible by 3. So 432 is also divisible by 3. We are going to look at the ones separated from the hundreds, the tens, and the ones, and see if the sum of the digits is divisible by 3. So in this, we have the sum of the digits. You can see here at 10, 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 2 is 5. So we're going to go through and circle all of the ones that are divisible by 3. 3 is divisible by 3. 6 is divisible by 3. 9 is divisible by 3. 3 is divisible by 3. 6, 9, 3, 6, 9, 3, 6, 9, and so on. You can see all of the orange or tan ones add up the digits to something that is divisible by 3. 12 is divisible by 3, 15, 18 is divisible by 3. So those values are also divisible by 3. Those original numbers are also divisible by 3. We already discussed that the ones in diagram D are divisible by 2. What are the numbers inside the circles in diagram E and F divisible by? And how do you know? Well, let's see. 3 plus 0 is 3. 4 plus 3 plus 2 is 9. 1 plus 5 is 6. 1 plus 0 plus 5 is 6. These appear to be divisible by 3. Four plus 0 is 4, but 4 is not divisible by 3, and neither is 2. How about diagram F? 432 appears in all 3 diagrams, but do they all follow the same rule? No. I see 2 is in D, but not in E, and not in F. 400 is in D, but not in E and not in F. I'm going to go through and highlight. This one is not in there. This one is not in there. This one is not in there, and this one is not in there. Oh. Well, now I notice the only one that's in both, or the only ones that are in both, are the ones that are in diagram F. So if it's divisible by 2 and it's divisible by 3, 2 times 3 is 6. So my thought is maybe these are divisible by 6. Kayla and Blake both determined that 134 is not divisible by 4. Explain how Kayla determined that 134 is not divisible by 4. Here we see Kayla broke 134 up into 100 and 34, then tried to divide each number into groups of 4. She knew that 100 could be divided into 4 groups, because that would give you 25, but she found that 34 cannot be divided into 4 groups. Can you use Kayla's method to determine whether a number is such as 1,234 is divisible by 4? How? Well, we know that hundreds are divisible by 4. So if we have 1,200, that's just 12 hundreds. So that piece is divisible by 4. Now we need to check if 34 is divisible. But we already said that it cannot. So 1,234 is not divisible by 4. Explain how Blake determined that 134 is not divisible by 4. Well, first he showed that 120 is divisible by 4. It's a multiple of 4. And he started at 120 and he skipped counts. 124, 128, 132, 136. And he realized, nope, 134 is not divisible by 4. Can we use his method to determine if 134 is divisible by 7? We know that 140 is a multiple of 7. So if we go backwards, that would give us 133. We're taking off 7. 126. But 134 would be in the middle, so it is not divisible by 7. Determine whether the number 272 is divisible by each of the following numbers. Explain your reasoning. Yes, it is even. The last number is an even number, so it is divisible by 2. For 3, our rule was to add 2 plus 7 plus 2 We add those digits together. That's 9, 10, 11. 11 is not divisible by 3. So, no, this one is not divisible by 3. For number 4, or for C, for 4s, well, we know 200 is divisible by 4. Is 72 divisible by 4? We could also try, we know 4 times 70 would give us 280. So if we skip counted backwards, we take off 4, that would put us at 276, 272. Yes, this one is divisible by 4. And 72 is also divisible by 4. 6. We said if it's divisible by 2 and by 3, then it's divisible by 6. But it was not divisible by 3, so it is not divisible by 6. How about for 8? 8 times 30. 8 times 3 is 24. So that put me at 240. If I skip count, that'd be 248, 256, 264, 272. So yes, it is divisible by 8. How about 9? It wasn't divisible by 3, so it can't be divisible by 9. The Ancient One has been counting since the dawn of time. He has just reached the number. That would be millions, billions, trillions, quadrillion. Okay, 1 quadrillion 10. What is the next number the Ancient One will count that is divisible by 2? Well, this would be an 11, but that's not divisible by 2 because it doesn't end in an even number. So the next thing that would be divisible by 2 is 1 quadrillion. Make sure I got enough zeros here. And 12. How about the next one that's divisible by 5? Something that's divisible by 5 ends in a 0 or a 5. So the next one would be 1 quadrillion and 15, because it ends in a 5. Then the one after that would be 1 quadrillion and 20. How about divisible by 3? Right now I have 1 plus a bunch of zeros, plus 1 is 2. But to be divisible by 3, the sum has to be divisible by 3. So we need an extra 1 in here. That would be 1 plus 1 plus 1 is 3. So that is divisible by 3. Divisible by 6. It has to be even. So this one won't work. And it also has to have a sum where its digits add up to something divisible by 3. So this one doesn't work. The next number, if I add them together, would be 6, right? I have 1, 2, 3. The next number that's divisible by 3 would be 6. So 1 plus 1 is 2, plus 4 would be 6. So that would work. And it's even, so it would be divisible by 2 also. One quadrillion and 14. Six, determine whether the statements are true or false. If the statement is true, justify your reasoning. And if the statement is false, provide a counterexample, meaning something that shows why it's false. If a number is divisible by 9, then it is divisible by 3. That is true. And we need to justify. If it's divisible by 9, it is a multiple of 9. And 9 is a multiple of 3. So if 9 is a multiple of 3, then that just means it's going to take multiple 3's to make up that number. If a number is divisible by 3, then it is divisible by 9. This is false. 3 is divisible by 3, but 3 is not divisible by 9. That would not come out to a whole number. Another counterexample we can think of is 12 is divisible by 3. That gives us a whole number of 4. But 12 divided by 9 would not be a whole number. How can we tell whether a number is divisible by another number without actually dividing? That's where those rules come in handy. To see if it's divisible by 2, we just look at the last number. If it's even, then it's divisible by 2. If it's divisible by 3, the sum of the digits, if we add up all the place values, that would be divisible by 3. For 4, we just look at those last two numbers, because the hundreds we know are guaranteed to be divisible by 4. With 5, it should end in a 5 or a 0. With 10, it ends in a 0. So there's some quick rules that help us figure out if something is divisible by a number without having to do division.